Thank you, Gwen, for that introduction. It's an honor to be here today. And with me is Tadeu Carneiro, the CEO of Boston Metal. I'm very excited for this discussion, both because Boston Metal is doing such important work in decarbonizing steel, which is such a big source of emissions, but also because Tadeu is another Boston entrepreneur like me, and I haven't had the good fortune to meet him before. So Tadeu, it's an honor to meet you, and thank you for being part of this event.
Thank you very much. Thank you to the organization for inviting us for this chat, and thank you for your introduction and for emphasizing the importance of decarbonizing steel to what is the major goal for our society, which is to move from the carbon era to a new era where we eliminate CO2 emissions. So that's our mission, to commercialize a process that we are developing to manufacture steel without any CO2 emissions.
And what is the origin story for the company? How did Boston Metal come about?
The process is a platform technology. So it came with this idea of using electricity to manufacture metals in a sustainable way. And we, at one point in the life of the company, we picked the bet of steel. It's a pretty obvious one because it's the one that it's the most significant in order to use this technology, which is to pass electricity to a mixture of oxides and get the least stable one to be split apart. And so by design, we make the iron oxide from the iron ore to be the least stable. As you pass electricity in the cell, you break the bonds apart, so you get the iron for your steel, and you emit oxygen as a byproduct. So you can do that with other oxides as well. So it's and that's how the company started, by looking at different ways to manufacture metals in a more sustainable way, cleaner way.
And can you talk a bit about how metals like steel are manufactured the traditional way, and also maybe just a bit on the scope of the problem as it relates to climate and emissions?
Sure. So steel is manufactured the same way for millennia now. So the Iron Age is 1200 BC, as you know. And so you get iron ore, you mix with coking coal in a furnace, and you burn by blowing oxygen and some form of oxygen on it. And then the carbon will somehow reduce the iron oxide in the iron ore, and you get your pig iron. So that's and this process is steel is one of the most important engineering materials in the world, and will continue to be. So this way of manufacturing steel is used in 70% of all the steel manufactured in the world. Only 30% of steel is manufactured coming from remelting scrap. So 1.5 billion tons of steel manufactured this way by mixing iron ore with coking coal. And that results in 9% of all the CO2 emitted on Earth today. So it's a big chunk. So if we want to decarbonize and move on to less CO2 emissions, that's one of the most important industrial components to solve. And again, it's not just 9% of all the industrial CO2 emitted. It's 9% of all CO2 emissions. So it's a very large amount, and that's why it is very relevant.
I feel like one of the justifications for things like offsets existing is because of certain sectors that are big sources of emissions that are hard to decarbonize, that will take decades, even in the best case scenarios. And steel is one that gets brought up frequently. How do you respond to that? Will it take decades to decarbonize, even in the best case? And what is it about decarbonizing steel that makes it so challenging?
Well, it is arguably the most difficult sector to decarbonize. It is very hard. Uh, it's the incumbent method is being developed for years and years, hundreds of years. So it's a very efficient way. You always have very cheap raw materials in order to do that in an efficient way to get your steel manufactured. So to eliminate carbon from the equation, you have few options, right? So that's why it makes very difficult. Electrons, so electricity is one of the options. So and it is the most effective one as we see it, and one probably the only one that can solve the whole problem of almost 2 billion tons of steel per year. It is being it's being catalyzed by all the investment that's being done in generating green electricity as well. So you obviously need to have green electricity, otherwise it defeats the purpose. But with all the investments in wind and solar and sustainable ways to get electricity, greener electricity, that makes you think of being possible to use electricity as the reducing agent to transform iron ore into steel. So that's but it's very difficult to do that because it's being a tough technology. It's not something that you can iterate very simply. So we are at the stage of getting our pilot plant developed in a way that we will, on a smaller scale but semi-industrial scale, get to manufacture steel continuously from iron ore using our technology before the end of next year. So that's where we are today.
Uh-huh. And I know the company's been around for a while and you've raised quite a bit of capital. Can you just set the stage for the audience in terms of where you're at today from a business milestone standpoint, how much capital you've raised, and also the sources of that capital? And feel free to talk about the individual firms, but I'm most interested in, was it equity? Was it debt? Was it non-dilutive capital? And just how you think about fundraising for this type of deep tech startup in general.
Yeah, no, that's very interesting. The company was formed in 2012. I mean, physically started to operate in 2013. The first 4 years, 5 years of the company was just going from the coffee cup size laboratory to a semi-industrial model and pot, and that was done to test different metallic systems, not just steel. So that was the first phase, and then during that phase, we used we lived out of grants, government grants, but it was a very small setup. So we were 6 or 7 employees. So in 2017, we went for Series A, and late last year, early this year, we closed Series B. So in total, we raised so far close to $100 million, and Series B
And
round of
still, and
financing.
still pre-revenue, correct?
It's still pre-revenue. That's correct. Yes,
Uh-huh.
yes.
Wow,
So
that's amazing.
yeah,
That's such a big challenge of these deep tech companies in general because this technology needs to exist and this sector
exactly.
has to get decarbonized. But gosh, that sounds like a lot of risk.
That's exactly right. And and this is an interesting thing how the thing evolved. In 2018, due to the background, I went to visit the steel companies, and it was a totally different scenario at that point compared to what it is today. It seemed to be too early for them to go on with that. The steel industry, as you know, it's sort of a very conservative industry. I mean, some think it's the most conservative, and they were skeptical about our technology, and at that point to lead the process. So we then shift gears and we found BEV, Breakthrough Energy Ventures, who really liked the idea because they were, they came as an entity to really look for those who could take care of big chunks of CO2 emission. And so they led Series A, BEV, with also the participation of Prelude Ventures, Nat Simon's fund from the West Coast, the engine built at the MIT, and also OGCI, Oil and Gas Carbon Initiative, which is a consortium of the 13 largest oil and gas companies. So that was the composition of Series A. We were oversubscribed compared to what we needed at that point. And then when came Series B, late last year and early this year, we were able to get the confirmation of these four initial shareholders that they came strong again for Series B, and we added six other shareholders, and the six were PIVA, which is the Petronas money, and also another consortium from the North American EIP supplying electricity, EIP, and then we got also the private side of Fidelity to join, which doesn't need any introduction, and then two of the four largest iron ore suppliers in the world, so Vale from Brazil and BHP from Australia, and BMW at the end of the chain. So we end up with a syndicate of investors, 10 giants who really want this to happen and are backing us to get to the final journey. So the next milestone for us, as I briefly mentioned before, is to get our pilot plant here in Massachusetts running continuously to produce steel on a semi-industrial basis with real-life iron ore. And then from that point on, we will then build the first industrial cell. We are already selecting sites to do that, and we expect to be able to commission an industrial cell, the first one in 2024. And then by mid-decade we should have then the first demonstration steel plant with some, get the necessary partners to build the first demonstration plant by mid-decade. So fairly aggressive timetable, but we really excited, and we believe that it's very doable.
So I have a three-part question. One is, who do you envision the ultimate customers are for the Boston Metal offering? Two, how much involvement do those customers have in the early phases and the years leading up to you being revenue generating? And then three, what's the value proposition to them, and how much, if at all, do you talk about climate?
Yeah, well, sure, very, very good. So here is the thing. So the final customer will be steel manufacturers. So this technology can be plugged into the integrated mills. So today they have molten steel coming from a furnace that's called the basic oxygen furnace. So they would produce a pig iron in a blast furnace, transport to this BOF furnace, and get their liquid steel. Our cells would replace all this equipment that is carbon intensive and emitting lots of CO2, and then we'll give you an even better liquid steel to go into the ladle metallurgy that exists today, to a caster, and to the rolling mill roll. So you have that possibility. You can also get our cells manufacturing the liquid steel plugged into mini mills that recycle scrap, and have our liquid steel being added, complementing the charge of the EAF furnaces in their process. That's also possible. But then there is another one that can disrupt the industry as well, which is the following: if you have the iron ore suppliers have electricity at the mine, you can bring the cells to the mine, and they can ship a metallic instead of shipping iron ore. So that's also another way that the process can go. So that's to take care of who would be the customers here. We don't see ourselves as steel manufacturers or plant builders. So the business model will be one based on licensing the technology and getting ourselves associated with partners that can make the technology being implemented very efficiently and quickly. So, but it's
And
pretty
these are
much based on
primarily the partners who are making steel the traditional way already.
it's they are very interested now. So their interest transformed amazingly in this 4 years. I mean, this is since a 1 year now. They are very interested, and all of them of notice are following what we are doing very closely. So we are
Uh-huh.
talking to all of them, and they
Why?
all want.
Why do you think they're becoming interested now?
Well,
What's motivating
the
them?
pressure on them is amazing to solve uh, the problem of CO2 emissions. I mean, you've seen the most important ones, the largest steel manufacturers in the world. They are already making the pledges to become carbon neutral by 2050, and they need a roadmap, and they need a very effective technology to make them accomplish that. And we believe that our technology is the technology that will ultimately prevail, or at least will be the dominant one. I mean, there are several other ways to think of the problem. I think more than one will exist, but ours will, I believe, be the most effective and the most competitive one once we become commercial. So they are very, very interested. There is an aspect of our technology that I would like to emphasize that caught the attention of lots of them, or all of them, which is the following: the the gang that you have, those impurities that you have in the iron ore at the mine, they are oxides, like simple oxides like alumina, silica, calcium, magnesia, that are part of the electrolyte in the cell. So therefore, you don't need to process the iron ore in order to add them to our cell, first of all, because everything is going to be molten. And what is impurity in the iron ore is actually part of the electrolyte in our cells. So you don't need to have very rich iron ores in order to get your steel the way you need when you go in a direct reduction way, for example, with using natural gas or hydrogen as a possibility as well. So this is what makes our technology very competitive, and everybody interested to see when we are going to be commercializing this. We have a world conspiracy in our favor to get us to be successful as soon as possible.
How important is mission alignment when it comes to investors? And said another way, is there a role for greedy capitalists in decarbonizing these hard to decarbonize sectors like steel, or do you really need to be doing it more because it's the right thing to do for society?
Well, as I mentioned to you briefly, telling a little bit of our history, it started with the latter. I mean, we had to find those who believed that something had to be done because it was the right thing to do. But now it's becoming clearer that, at least in our case, this is very competitive. If we have electricity, according to our calculations and our targets, if we have electricity priced below $30 per megawatt hour, we can be competitive with the incumbent today without a carbon tax. So this is very appealing and very important in order to make this happen.
Tadu, what do you worry about the most? If Boston Metal fails, in hindsight, what do you think the reason could be?
Well, if all of a sudden society abandons the idea that CO2 is important, and therefore I think that's not going to happen. It is important. I don't need to convince anybody here, uh, as you made clear in your introduction. And therefore we have to find a solution to solve to abate CO2 emissions from steel manufacturing. So it's there is an amazing demand for green steel, and we can see that, and we've been approached by uh, the end users. They all want to have green steel in their solutions, and therefore the pressure is on us to deliver the technology commercially, and I don't see a problem. Getting to the end of the journey. It is obviously a company that has an R&D based component. So whether we are going to take 5 years or 4 years or 6 years, that's what is the variable here in order to get the process all de-risked and scaled up. But we already proved the concept on the lab scale, so it's a question of system engineering to get to the end of the journey.
Tadu, we have time for one last question, and that's just for anyone in the audience who is trying to find their spot and is maybe an entrepreneur or an operating executive or in some type of functional role in startups but wants to work on climate. What advice do you have for them as they try to sort through the right place for them?
Uh, I mean, we already had this environment mapped out very well. And there is a tendency to go after those problems that represent a big chunk in CO2 emissions. So the idea here is to be able to show how your piece in the puzzle impact in a big way the whole puzzle. And these things, sometimes it's not easy to see that big impact. So my suggestion is that you understand the problem you are trying to solve, and explain, to the society as a whole, how that solving that problem will impact the whole puzzle. So I think that's the way to go. In our case, it's easier to show the problem. I mean, you can calculate very easily, the amount of CO2 that's coming out of the 2 billion tons of steel that is manufactured every year. I mean, some other ideas may be more difficult to show the impact that they have in the whole picture. But that's the key thing, is to emphasize and show how important it is.
Great. Well, I wish we had 2x or 3x the time that we've had today, but super interesting discussion, important work that you're doing at Boston Metal, and I wish you and the whole team every success.
Thank you so much. Thank you for inviting us to participate, and looking forward to participating again to show our progress. Thank you.